Hi guys, so today we're going to start covering the AB exclusive non-calculator free response questions. So we're going to start with AB5, and this was our particle motion question that comes up on the AB test every year. So in this question, we're given the equation of the position of particle H and the velocity of particle J. So this is an important distinction. Or the first thing we're going to need is part A. We're going to find the velocity of particle h at time t equals 1, which would be v of h of y in standard notation. So first, to find the velocity at a certain time, we're going to find the general equation of the velocity of the particle. So this would be v sub h of t equals um, and then we're going to differentiate this x prime of h of t equal, and then since the original was e to the t squared minus 4tu, this is going to become e to the t squared minus 4t times the derivative of what's inside 2t minus 4. And then when we plug in 1, this becomes v sub h of 1 equals e to the 1 minus 4 times 2 minus 4 equals negative 2 e to the negative 3, or negative 2 over e cubed. And this is answer part A. Very straightforward. And I'm assuming they'll give you 1 point for stating the relationship and 1 point for the answer. In part B, we're asked for particles H and J move in opposite directions, and this happens when v sub h of t and v sub j of t have opposite signs. So create a sign table for each particle, and then I'm going to create a table here. There's going to be quite a few rows here. I'm gonna make a few extra just in case. Time v h of t and v sub j of t. This is going to be important. We're gonna have 0 here in between, and then 2, 3, 4, 5. And v sub h of t, once we see from here, the e term is always going to be positive because that it doesn't have a negative part of it. But in this term is all that matters. 2t minus 4, it would be 0 here, and it will be negative for every value to the left and positive for every value to the right of it. And for v sub j of t, that's given to us. It's 2t times t squared minus 1 cubed. 2t is always going to be positive because we're only dealing with positive terms. And this t squared minus 1 cubed, this is going to be negative for x is less than 1, and then positive for greater than 1. So we're going to put it here, and then 0 here, and then positive for the rest of the way. And then look, in between t equals 1 and 2, this is where we have differing signs, and we're going to say since the velocity of particles h and j have different signs from the open interval from 1 to 2, particles h and j move in opposite directions on the time interval 1 to less than t less than 2. And this answers part B. And in part C, we're asked, is the speed of particle j increasing or decreasing or constant at t equals 2? So for this, we need the acceleration. A times j of 2 equals v prime sub j of 2. And this would be, we will have to use the product rule. So this would be 2 times t squared minus 1 cubed plus 3 6t times t squared minus 1 squared times the derivative of what's inside, which is 2t. And when we plug in 2, this would become 2. This would be a positive value since we have 2 times 4 minus 1 cubed plus 12 times 4 minus 1 squared and 4 times 4. And all we have to say is this is greater than 0. And we're given that velocity is, and we saw that in part B already, since the velocity and acceleration of particle J at t time t equals 2 have the same sign, speed of particle J is increasing at t equals 2. This is our solution to part C. And in part D, we're going to find the position of particle J at t equals 2 given an initial condition. So here we're going to use the Fundamental Theorem of Calculus and say x of j of 2 equals x of j of 0 plus an integral from 0 to 2 of v sub j of t dt, since remember this is the rate at which the position changes. So when we integrate the rate function, we get a net change in position. So this simplifies to x sub j of 2 equals 7, which is given the problem, plus the integral from 0 to 2 of 2t t squared minus 1 cubed dt. And here we're going to have to do a u sub. So let u equals t squared minus 1 du equals 2t dt. So the 2t outside would cancel out, but then we would have to change the boundary integral to t squared minus 1. So this would become x sub j of 2 equals 7 plus integral from -1 to 3 of, because this, when you do a u sub, you have to replace the thing with t squared minus 1 instead of using the original bounds. So this would give you of u cubed du, and this equal to 7 plus 1/4 times u to the 4th evaluated between -1, 3. So this would be 7 plus 81 over 4 plus minus 1/4 equals 7 plus 80 over 4 equals 7 plus 20, and this would be equal, give us 27 as a part D answer. That's it for this one. It's just a basic particle motion question. It's direction, speed, acceleration, and position, velocity, all these connections that often show up. It should give you a head start in your physics C class, as always, if you're also taking that. So that's a pretty straightforward one. I'll see you for last problem next time.